Patrick Cook here. Thanks for joining me in session number 15 of our Mastering Mandelbulb 3D Formulas tutorial series. Now, we've made some pretty good progress. We've been talking about the formulas window, going through the various functionality. The last session, we were talking about properties, okay? And with some of the rules of thumb, not all formulas have properties. Usually, the properties are numeric values. I personally have never seen a non-numeric value, but who knows, it might exist. Maybe an A or a B, something like that. I don't know. I haven't seen any. We don't know the range of the formulas, of the properties for the formulas, so all you can really do is experiment. The values that you plug in do not save back to the M3F source file, so there's no risk of you actually modifying or damaging the M3F file. Let's talk about the formula categories, okay? Now, if you recall from earlier sessions, we have what are called 3D, and we have 4D, and we have 3A and 4DA. We also have the ADS and the DIF. Now, basically, in the mind of the developers of the Mandelbulb software, they have a pretty good idea what the difference is between a 3D and a 4D. My understanding is that there's a particular property that differentiates between a 3D and a 4D. Let's just see if we can kind of see it for ourselves. Now, I'm just going to pick Axion C. That's a 3D. Now let me take another one here and pick, I don't know, Beth 1241. Okay. Now from my own experience in reading, the 4D have one particular property called a WAD. Now I'm not entirely certain what that property does, but that seems to be the differentiating factor between a 3D and a 4D. For purposes of working with Mandelbulb at a creative level, which I think is what we're trying to do here, you're more interested in not so much the category as you are what the formulas will produce in terms of a graphic on the screen. All right, let me just pick this Axion C on formula number 1. Let's calculate. All right, so that's my basic graphic. All right, let's get our where's it? Calculations up here so we can see the DE stop and various other quality related properties. Okay. Now, both the 3D and the 4D are what are called Escapetime formulas. Now, if you recall back to a previous session, I was talking about how the equations are run, the formula is run or executed by the Mandelbulb3D main software, and it determines a point, or the point is reference to a pixel, and if the point falls outside of the R bailout, that point won't be shown as a pixel. So only those points where it falls within the R bailout, or what's referred to as the orbit, okay, all right, So now both the 3D and the 4D are referred to as escape time, which means that if the value that's been determined by the formula falls outside of the orbit, it is thought to have escaped. It's not displayable. It won't translate into a pixel on the screen. All right, the value has escaped. All right, that's a basic definition of escape time. Where formulas are designed, where their math is designed to follow that behavior, if it's outside the R bailout, outside of the orbit, all right, it is thought to have escaped. And very often what that means in terms of math is that the value is so large or so much closer to, say, infinity, that the value of that particular formula isn't meaningful in terms of writing a graphic on the screen. All right. Excuse me. So the 3D and the 4D are escape time formulas. They follow that pattern of if the value is within the R bailout or the orbit, it'll show. If not, no pixel. Now, you also have 3DA and 4DA formulas. Now, the A stands for analytical, and basically what it means is that those formulas are designed so that the Mandelbulb main software will do its best to determine what the best DE stop is for that particular formula. All right. My understanding is, my experience is that the 3DA and the 4DA, the analytical, the allowing the application to determine the DE stop, is actually pretty good. It's actually pretty accurate. Typically, a 3DA and a 4DA formula will run more optimized, all right, when it's executed, compared to a standard 3D and a standard 4D formula. In other words, the 3DA and the 4DA are more efficient, and you will tend to get better quality because the Mandelbulb3D core code is handling the DE stop values, or handling the quality to make it a little bit more simple. Now, that doesn't mean that you should always use just 3DA and 4DA formulas, because those formulas may not be applicable or even best for what you're trying to accomplish, okay? But the difference between the 3D and the 3DA is that the A is analytical, where the application will try to come up with its own DE stop, and is typically efficient and better quality. And that would also be true between the 4D and the 4DA. Okay? All right. So, okay, let's end this session right here. Digest that. Let's get some coffee, and we'll pick it up in the next session. So I'll see you there.